Okay, here we go, 11.1. So 11.1 deals with a lot of circles, just the basics dealing with the outside of the circle. So most of this unit, chapter 11, is going to be dealing with area, but not this particular section. This is the one section that deals more with perimeter, which is kind of what circumference is. So circumference is the distance around a circle, or it's the perimeter of a circle. The formula, there's actually two formulas you can use. Circumference can equal 2 pi times your radius, or your circumference can equal pi d, which is diameter. Okay, so the first one just says find the circumference of a circle that has a radius 9. So if it has a radius 9, then we can use the 2 pi r. So this is kind of how this works. Circumference equals 2 times pi, if we're following the formula, times 9. Okay, now the way that we leave circumference is we leave it in terms of pi. So your actual answer would be to take 2 times 9, which is 18, and your circumference would be 18 pi. And then it would be centimeters, not centimeters squared, just regular old centimeters. So this is what's called in terms of pi, if you ever hear that, or this would be your answer, your exact answer. So I didn't have to do any sort of rounding. If you did put this into your calculator, 18 times pi, to get a decimal answer, you would have to round at some point. So then that wouldn't be an exact answer. That's why it's called the exact answer. Now, if you're looking at your calculator, all your calculators should have a pi button. So get away from using 3.14 and actually use a pi button. Okay, this one goes backwards. It says find the radius of a circle whose circumference is 26 meters. Notice that there's no pi there, so it's not in terms of pi, so we have to be a little bit careful here. So when we go circumference equals 2 pi, I actually don't know my radius. So this 26 number does not go in for the radius, it goes in for the circumference. Okay, so it would be 26, not 26 pi, because there's no pi there. That meters is just a label, so that doesn't come into our equation. And then it would be 2 pi radius. Okay, so right here, this is where you can get into a little bit of a trouble, because you hopefully want to divide both sides by 2 pi. If you're using your phone calculator, or if you're using a calculator that has parentheses and you don't actually put the parentheses in, you're going to get the wrong answer here. So when you divide 26 by 2 and pi at the same time, there always has to be parentheses, because there's 2 parts here you're dividing by. Otherwise, it'll take 26, it'll divide it by 2, and then it'll multiply it by pi, so your answer for the radius will actually be bigger than the entire circumference, and you don't want that. So we're going to take 26 divided by parentheses 2 pi. And we'll get our final answer there. So 26 parentheses 2 pi is 4.14. Radius equals 4.14. Now, if you're at home and you're not using a nice calculator, or you're worried about not getting the right answer, another way you could do this to kind of get around having a nice calculator or having a graphing calculator is you could take 26, divide it by 2, hit the equals button, get an answer, so that's 13, and now take 13 and divide that by pi. So divide them one after the other instead of trying to do them both at the same time. Okay, moving forward. So now we're doing arc length. So arc length is a portion of your circumference. So in a circle, circumference is the distance all the way around the circle. So arc length is going to be just the length of some portion of the circle. So it's only like this length. So that is an arc on the circle, and how long is that arc? That's what arc length is. Okay, so arc length is a length of a curve along the circumference. So it's not the entire circumference, it's just a length along the circumference. There's a formula for this, and we're going to really have to break down the formula so that you understand all of the parts, but I'm going to write the formula down first, and then we can talk about it. So the formula is the measure, not the length, that's different, the measure of the arc, written like this, over 360, and we're going to multiply that times the circumference of a circle. So basically, we are doing a fraction of the circumference. That's what this means. Okay, so how do we get this number here? Well, a circle is an entire 360 degrees, but what you're going to see below is I don't want the entire 360 degrees. I only want 60 degrees of that 360. Okay, so if I want to find the length of the arc between A and B, so the length of this arc is found by, so when it says measure of AB, the measure is the degree measure. The degree measure here is 60. So to find the arc length, I'm going to take the measure of the arc, not the length, the measure, that's the degrees. And I'm going to multiply that by 2 pi times 8. Okay, so this is the circumference, but I don't want the whole circumference. I only want this much of it. I only want this fraction of the circumference. Okay, so now we go ahead and we multiply this out. So when you type this into your calculator, you can go ahead and type 60 divided by 360 times 2 times 8 and just get a number for that. Notice I did not put the pi in there, okay, because we're going to leave this in terms of pi. So it would look like 60, let's let it, there we go, adjust. So 60 divided by 360 times 2 times 8. Now you could also just go times 16. Okay, now it gives me that. Now your calculator may or may not, depends on what you're using, and I'm going to show you, there will be a video later on how to use Desmos, which is either an app on your phone or a website that you can use as a graphing calculator if you don't have it. But if you have this graphing calculator, remember you just hit the math button here, and your first option is a fraction, and you get your calculator to give you the fraction for that decimal, which is 8 over 3. So my final answer for this is 8 over 3 and then a pi. Okay, that's the easiest way to do it with your calculator. Another way to do it is you just have to do it out by hand. So if you do it out by hand, you just have to go through the process of reducing and the multiplying. So I will we'll do that on the next one. So if you've seen how to use a calculator for that. There'll be a video out on Desmos if you want to download that if you don't have a graphing calculator at home. But here's the last example. So the next one here, we're going to do the measure of, this one would be not AB, obviously it would be GH. And when we do arc length, that is going to be the shortest distance between the two. Okay, just for ease of conversation during this time. So GH, so the arc GH here, the measure of the arc GH, remember, is the degree measure. So the degree measure is 120, and we'll put that over 360 and times that by the circumference, so 2 pi radius. So we'll go 120 over 360 times 2 times pi times 11. Okay, so if I just do a quick simplification of this, I'm going to cross out the zeros, okay, because I can easily do that reducing. And then here I'll take the 2 times the 11, which is 22, and then pi. Okay, so I'm doing this one out by hand, no calculator involved. So now I'm going to take 12 times 22, because this is 22 over 1, and then 36 times 1. Now, if it were me doing this, I would reduce it one more time before I did the multiplication, just because it would make it easier. So 12 and 36 can actually be reduced to be 1 over 3. And now it's a lot easier to go ahead and multiply, or you can multiply and reduce at the end, but that's just a little bit more difficult. So 1 times 22 is 22. And then 3 times 1 is 3. And then pi. Now again, if we were giving the exact perfect answer, we would also add on the back side here centimeters. Okay, last example. So this particular type here, this type is going to ask you, some of them is going to ask you for the length, some of them is going to ask you for the degree measure, and some of them are going to ask you for the circumference or the radius or something like that. So this one is a straightforward, it's asking you for the length. So that's just what we did here and here. So if you're trying to find the length, that's what we just did. Okay, this one does throw you a bit of a curve because it's giving you 9 as your diameter instead of giving you a radius. So you can choose, do you want to do 2 pi radius and know that the radius is 4.5? Or do you want to use the formula pi d and just use the 9? It's kind of up to you. Okay, so for setting it up, finding the length, that's what we've been doing. So the length would be 75 over 360 times, and then I would just go pi d. I would go pi times the diameter of 9. Okay, then you either use your calculator or you can use, or you got to do it out by hand to reduce this, to multiply and reduce this fraction. So I would maybe reduce the 9 and the 360. So 9 goes into 36 4 times. So this is 9 over 1, so I can reduce here. So it would be 75 over 40. And then this part right here would just be 1 over 1, so we're done with that part. And then I would keep reducing here, so reduce them by 5. Okay, so if you reduce 75 by 5, you get 15. Reduce 40 by 5, you get 8, and then pi. And again, if we're giving the exact perfect right answer, this would also have yards. Okay. Okay, now going to this one, it does show the arc length right here. And it's asking you to find the measure. So that's the degree measure. So it's asking you for this degree measure. Okay, so the measure of that. So we would put something like x over 360. Now, what you're going to see in later classes is they're going to use that theta that we used a couple of times with trig. So you're going to see that theta, but you can just put an x there. It might be easier for you to have an x there, but that's a theta. It's not a 0. It's kind of like that cursive O over 360 times, now here's our radius, times 2 pi times 15.28, and that equals 40. So here's the measure of the arc. Or sorry, the arc length is right here. And now we just work this backwards. So there's a couple of different things you can do. You can go ahead and take 2 times 15.28 if you want to kind of clean this up a little bit. But also know that pi is not over here. So this is definitely a rounded answer, this 40. So you're definitely going to get a decimal for your answer. So because there's no pi in here, if there were a pi right here, it would make life a lot easier. Because then we could cancel this pi with this pi. But because there's not, we can just go ahead, all three of these things, I'm going to put that into a calculator and just get a number. Okay, so I'm going to take 2 times pi times 15.28. Okay, now that's 96.007, so 96. So you've got theta, or x, over 360 times 96, and that's going to equal 40. Okay, so as you go forward, it doesn't matter if you get rid of the 96 first or if you get rid of the 360 first. So if I get rid of the 96, I would divide, I'd get a decimal, and that's okay because I'm going to multiply it by 360 after that. So you can either multiply by 360 first, you can divide by 96 first, or you can do them both at the same time, really. I'm going to go ahead and get rid of the 96 by dividing. So the opposite of multiply is divide. So if I take 40 divided by 96, I get theta over 360 is equal to 0.41666666. Okay, so then to finish up the problem, I'll just multiply the answer I have in my calculator times 360, and I get 150 degrees. So theta is 150 degrees. Okay, final one. This one is asking you to find the circumference. So this is the last type where we're actually trying to find this 2 pi r part of it. So when I write this down, I'm going to write it down a little bit different. It does tell you that the arc is 61.26. Okay, that's the arc. That is not the radius. It's not the diameter. It's just kind of hanging out there. These pictures are not fantastic. And they are super wonderful by doing this 270 degree angle measure instead of doing the smaller measure on the inside. Okay, so this is not the best picture. This is not something that you won't see this on the quiz, but it is something that we need to know how to do, and it's possible that you could see something like find the radius on the quiz for sure. So we're going to keep going with this problem. Let's go the measure of the angle. Okay, so that's 270. So the measure of the angle over 360. Now instead of writing right here, instead of writing times 2 pi r, I'm just going to write times the circumference. That's the circumference formula, and that's what I'm looking for. I'm not looking for radius or diameter. I'm looking for that big number, so I don't have to write 2 pi r. And then that equals 61.26. And now I just have to get rid of this fraction. Some of us like to get rid of the fraction all at once. Some of us like to do it one at a time. So if you want to do it one at a time, the first thing I would do is I would multiply both sides by 360 to get that out of the bottom. And then you're going to divide by 270. Okay, so I'll do it that way first. If you know a faster way, please attempt that one and see if you get the same answer. So if I times both sides by 360, I'm going to multiply that out of the bottom. I have 270 circumference equals it's a big number, 22053.6, so 22,053. And now I'm going to divide by 270. So it's okay that it's a big number because now I'm going to divide. And I get my circumference to be 81.68. Okay, now that is okay because that circumference should be bigger than the measure of the arc. So the measure of the arc is only from L to M. So whatever answer we get should be bigger because this number is the entire circle. Okay, if you flip a couple pages, what you're looking for is you're looking for the one that says, so we just did notes 11.1. If we flip a few pages here, you're looking for practice 11.1 is the practice. And we are just going to do the odds on this. So if you have a question or you don't know how to do a particular problem, you can send me, I don't know how to do problem number 1. Well, I can do problem number 2 to show it to you. We can work it through, okay? So just the odds on this one. If you want to do the entire thing for more practice, you are more than welcome to do so. And do remember that the answers are at the back of the packet.